Good afternoon, YouTube. Welcome back to another lunchtime study session. Today's session is going to be a little bit different. I think for the first time, I'm just going to try to come up with or implement my own challenge scenario. And I hope to be doing some more of these because it's more like a review and kind of like a checkpoint. So this is kind of like a milestone. This will be about implementing Intervlan routing using the router on a stick configuration and then controlling traffic between those VLANs using access control lists. So I think I'm just wanting to simulate like what a real small or medium-sized network could be like at a smaller scale, but what it could, start to look like. So let's go ahead and get started. We're going to need some network devices. We need a router. So we'll start with our router here, and then a switch, and then some end devices. So let's take some PCs, PC1 or 0 in this case, 2 and 3. All right, so what I'm thinking is that PC0 will be in a VLAN. Let's do that. I think this is fine. Fill color, yes. What's that going to look like? I don't want that. Select fill color. No fill, fill color, outline, select outline color. Okay. There we go. All right, and then the next one we'll do, I don't know, purple. All right. And finally, bluish. All right, so let's say now I want to put like a little note. Note. Let's say this is admin. This is dev, and this is our test environment. All right. So I'm going to put some rules that we want to achieve. So the rules are, we'll keep it simple, but admin can ping dev and test. Dev cannot ping admin. Test cannot ping admin. And dev and test can ping each other. All right, so those are the rules that we will need to configure for. So first things first, we need to create some connections. So let's do that. Let's just run automatic cable or fast Ethernet connections between our end hosts and the switch. All right, and then between the switch and the router. We're going to configure it so that each PC is in a different VLAN, virtual local area network. And because this is not a layer 3 switch, it can't do routing between VLANs, which is known as inter-VLAN routing. Meaning, once they're in separate VLANs, admin cannot ping test unless its packet is routed to the test VLAN, etc. And we're going to use a router on a stick configuration where your router has one line to your switch, but 3 or more, n number of VLANs can travel across that single line, across that single interface, versus having separate lines to each VLAN. All 3 can run along this trunk line. And so once that's implemented, that'll be kind of like step 1. That'll be our halfway point. Once that's implemented, they should all be able to teach or to talk to each other once again across VLANs, across their different VLANs. And then to implement these rules, we will need to add access control lists on the sub interfaces of the router to control the traffic that can go from one VLAN to the other. And that's how we will implement our rules for different pinging and whatnot. So let's do this. Let's go ahead and give some IP addresses to different things. So first of all, let's configure the IP address of 10, 10, 10, 10, and we will say 255.0.0.0. Okay, so that's 10, 10, 10, 10 is PC 0. All right, and let's do 20, 20, 20, 20 as the IP address for PC 1 in the dev subnet, or will be the dev subnet, and 30, 30, 30, 30. Oops, that's incorrect. That's not the default gateway. 30.30.30.30, subnet mask 255. Okay. So the 3 PCs have an IP address. The router, what port is it got connected to here? I think it's going to be gigabit 000. I don't know why I can't see the thing fly out to show me that. Let's do CLI. So the router is going to need an IP address for its main gigabit interface. So let's do that first. En conf t interface gigabit 000 interface gigabit 0/0 0/0, and we're going to say IP address. What's like a generic one? Generic IP address for router. Generic private. I can't remember what the private IP ranges are. 192.168.1.1. 0.1. Okay, so I should have remembered that. IP address 192.168.1.1. 255.255.0.0, right? All right, and then we're going to say no shut, and that will bring up the line. All right, and now, before we put anything in a VLAN, I think we should be able to ping across the hosts. All right, so let's just confirm that. Desktop command prompt. Can I ping 20.20.20.20, since it's in I guess it's in a different subnet, so maybe I can't. All right, that's fine. I think that might be expected. So what have we done? These all have IP addresses. These all have, or this router has an IP address, 192.168.1.1. Now let's go ahead and configure the default gateways to be the router's IP address, 192.168.1.1. All right, and the same here. Nope, config 192.168.1.1, and on PC2 192.168.1.1. All right, and now just to reconfirm, I don't think they should be able to ping once again, but I want to make sure that that's the case. And it should be. Okay. Yeah, that is not working. All right, so they all have a default gateway. This router, I wonder if they can ping the router. 192, Control C, Control C. I wonder why that does not work. 192.168.1.1. No, not yet. All right, so I think the reason this is not working because these links aren't defined on the switch yet. So the ports in use here need to become access ports, and I think I want to, show port labels when mouse over logical workspace. Okay. And I need to, so if I mouse over this, there we go. All right, so it shows me the port labels. And they, FA01, 02, 03, and 04 for the trunk. Okay, so let's configure these interfaces. So let's do en conf t interface fast Ethernet 01. All right, and what do we want to do? We need to make it an access port. So we need to say switch port mode access. And then we need to set it to switch port access VLAN 10, 20, and 30, okay? Switch port access VLAN 10. Okay, that's created. All right, and I think that's it for that part. Now we'll do exit. We'll go into interface fast Ethernet, what was it, 0/2. Switch port mode access. Switch port access VLAN 20. Exit, and then fast Ethernet 3. Switch port mode access, switch port access VLAN 30. And exit. All right, and now the trunk port, which is going to be this line here, this port, FA04, I believe, if I can hover and it will show me. Yes, FA04 on the switch is going to be a trunk port, so that'll look slightly different. Okay, so interface fast Ethernet 04. This is going to be switch port mode trunk. Okay. Switch port trunk question mark allowed VLANs. What VLANs can travel along this trunk line? That's going to be a list 10, 20, and 30. And I believe that is it for this one. All right, so now that that can work, can we ping from PC to PC? I would believe yes. Can we ping 2020, 2020? Is it going to go and complete ARP and then start pinging as expected? It is not. All right, so maybe that won't work until we configure the sub interfaces on the router. So let's do that. So I think this configuration is all complete. This configuration is complete. So let's do these sub interfaces. All right, so we are in an interface right now. So we need to do these sub interfaces. So we're going to configure a sub interface for VLAN 10, a sub interface for VLAN 20, and a sub interface for VLAN 30. And each sub interface will have its own IP address and maybe a couple other things. Let me see. So interface gigabit O/O dot 10 is how we do this. So now we have a sub interface. Okay, and then we're going to say IP address 10.10.10.1, let's say 255.255.255.0. I think that makes sense. Question mark? Okay. Configuring IP routing on a LAN subinterface is only allowed if that subinterface is already. Oh, okay, so we need to do. We need to say question mark encapsulation question mark .1q VLAN 10 question mark. Okay, so that is what we needed to do first. So that means when packets come out of that, or frames maybe I should say, come out of that port, they will be tagged with a VLAN 10 tag or addition to the Ethernet header. All right, so then we will do the same thing, 10.10.10.1, and exit. Okay, now let's do the same thing, but for the .20 subinterface. Okay, and we are there, so we need to do the same encapsulation, but for 20. And then we need to give it an IP address, and we'll say 20.20.20.1. All right, and exit. And then finally, the third one, .30. Okay, that's up, and we'll say encapsulate .1q30 and give it an IP 30.30.30.1, 30.30.30.1, and exit. Now I wonder if we can ping across VLANs. So let's ping 20.20.20.20. Okay, so ARP completed, and we are able to successfully ping. And can PC1, for example, ping PC the 30.30.1. All right, so ping 30.30.30.30. I would expect there to be ARP resolution and then 3 packets or 3 exchanges to complete successfully, which is what happens. Okay, so we have implemented router on a stick. So this is the halfway point, I would say, which means that hosts in separate VLANs can now communicate across VLANs with one another utilizing a router. This can also be done with a layer 3 switch. And not only utilizing a router, but utilizing a single port on a router. And that single port gets subdivided into sub interfaces, each with its own configuration that allow for traffic from its particular VLAN to travel and then get routed to other VLANs, which wasn't possible until that configuration was in place, as we saw. Okay, that's great. So that's exciting. That part is done. This is router on a switch. And this is actually, I was thinking about what exercise would be a good benchmark for kind of like where I'm at currently. And the router on a stick, I think, is a good one because it just requires some switch configuration, requires router configuration, IP addressing, encapsulation, etc. And you can, in fact, if I do simulation mode, and let's say I want to ping PC1, ping 2020. All right, so looking at this frame, oh, this is an ICMP message, so it's not quite a frame. What I want to take a look at is the Ethernet header, preamble, start frame delimiter, destination address, source address, type, etc. Okay, now my expectation is that once the packet or frame gets up to the subinterface of the router, it will come back out on its way down to PC1, and once it comes back out, it will have an additional tag, an additional VLAN tag applied to it. So let's just try to confirm that. All right, and let's say, okay, it's going back down now. What does it look like now? Okay, so I already see a .1Q header, inbound PC details. All right, and now you can see there are some additions, in particular these two fields. This, I believe, TPID has to do, let's see, 1 second, I'll just say it. What does the TPID field mean in Ethernet? The Ethernet frames, the tag protocol identifier field, TPID, is a 2-byte field within a VLAN tag used to identify the frame as VLAN tagged. Okay, so it is VLAN tagged. I believe TCI, this hexadecimal 0014, will map to the VLAN number, but let's just confirm that. What is the TCI field in Ethernet header? It's a 2-byte field within the IEEE 8021Q VLAN tag in an Ethernet frame. It contains information about the VLAN and the frame's priority. All right, so it contains the VLAN identifier, 12-bit field to which it belongs, and I believe that would be 10. It's probably hexadecimal for 10. What is hexadecimal? Hexadecimal for 10. It's A. And what do we have here? 0014. That makes a whole lot of sense to me, but regardless, it's tagged with a VLAN tag. Okay, so we know that frames are tagged with the appropriate VLAN tag when they leave the router subinterface. Let's just go back to real time. All right, so now we need to control some of this traffic. We know that admin can ping dev and test. Dev cannot ping admin. Test cannot ping admin. Dev and test can ping each other. Down the road, I think I'll do similar labs, but implementing more, I guess, maybe realistic scenarios. Maybe this is a realistic scenario, I don't really know, where admin is allowed to SSH into any of these or telnet into any of them, and they obviously can't go back and SSH into admin, something like that. Ping, I think, is interesting because, first of all, it's sort of, a specific protocol, ICMP protocol, and it's like a two-way sequence. So a request and a reply, comes back. And so it's kind of tricky implementing control lists, or traffic access control lists, because stuff needs to get through coming back to get the full life cycle of the ping to be successful. So it's just kind of interesting, I guess. All right, so what are we going to do? I think we're going to implement extended access control lists inbound on the subinterface 20 for the case of dev and the subinterface 30 for the case of test to deny ICMP echo requests to the admin VLAN, but allow other traffic from these subnets or these VLANs elsewhere. And I think that will help us achieve what we want. So all these are going to take place on the router in the subinterfaces. So the first thing I'm going to do is say IP access list extended, and we're going to call it dev. All right, so we need to create the access list first. And the first item or line in the list is to deny ICMP echo requests coming from dev out to admin. We're not going to allow the dev VLAN to request pings over to here, going this direction and back over to admin. All right, so deny what? We're going to deny ICMP from what source? 20.20.20.0, and then we do wildcard masks, 0.0.0.255. So deny everything in the 2020s subnet going as the source and to the destination, to the admin subnet. All right, and in the case of ICMP, you can specify which part of it, and we want to specify the echo part, not the reply, because replies will need to come back through and will need to successfully make it to the 10 subnet in order to respond to pings coming from admin to dev. So there's that. So deny that, and then next we will permit IP from 20.20.20.0.0.0.255 to anything else. All right, and that alleviates or gets rid of the implicit deny at the end to allow other traffic to come through that we will need to respond to pings from admin. Okay, so now this is done. We've created our access control list, and now very importantly, we need to apply it to a subinterface in this case. So we're going to say interface gigabit, and it's 0/0.20. Okay, so we'll go to the subinterface. And then we'll do IP access group, question mark, dev in. I believe that's it. All right, so now let's see if this is configured correctly. Can admin ping dev? Let's say ping 20.20.20.20. Admin can ping dev. Can dev ping admin? Ping 10.10.10.10. It cannot, and we know that it is being blocked by our ACL because we get destination host unreachable. If it wasn't being blocked by our ACL, it would just time out, like we saw in the earlier part of this video where we were trying to ping different things and you go the full 5 seconds, etc. So this is a good indication that it is getting blocked. And I think we can say, let's see, do show IP access lists. All right, so when I run the ping again, we can bring this up again and see them increment. So right now, there were 4 matches for each, and we'll go ahead and ping, let's say, for example, we'll ping back to 10 again, and we'll capture some more, and we'll do this. All right, so now there were 8 denials, and so we can see that, yes, the access list is working. All right, so admin can ping dev and test, okay. Dev cannot ping admin, which it cannot. Test cannot ping admin. So we need to do a similar thing here where we create another access list. Let's say IP access list, question mark, extended, we'll call it test. And we're going to do a very similar thing, but we're going to deny ICMP echoes, ICMP from the 3030s, 0.0.0.255 to the 10s, and we only want the echoes, the requests, all right? And then we will do permit other traffic, all of other IP traffic from 30.30.30.30.0, 0.0.0.255, anywhere else. And then we will jump into the subinterface .30 for the test VLAN and apply the access group that we just created to access group test in. All right, and now let's see. We would expect test not to be able to ping admin, but admin to be able to ping test. So let's try that. So here we are on admin, ping 30.30.30.30, and that is successful. Now, vice versa, let's do desktop, blah, blah, blah. Can test ping 10.10.10.10? No, host unreachable. That's a good sign. All right, now can dev ping test and can test ping dev? So we're going to say ping 30.30.30.30. And we can. And because it's a two-way interaction, I know that this is going to work the other way as well, but let's just confirm. Ping 20.20.20.20. And that works. So admin can ping dev and test. Dev cannot ping admin. Test cannot ping admin. Dev and test can ping each other. All right, so that is the lab. A simple one, but it feels good. It's a good benchmark, like I said, of kind of where I stand or where an individual might stand in their learning journey when it comes to networking and the CCNA, et cetera. Can you implement router on a stick successfully and manage the traffic in some way that moves across your sub interfaces? And again, you'll, by doing this, get exposure or more exposure to inter-VLAN routing, creation of VLANs, associating of them with trunk links or trunk ports, access ports, router configuration, sub-interface configuration, access control list configuration, and then knowing how to properly place access control lists on router sub-interfaces to manage traffic in the way you want. The rules in this case, I don't know. I assume this is realistic. I've never configured a network professionally, and so I can see why you would want to ping from one place but not allow pings from another. And I'm sure it is more likely that the relationships will be more complex to allow for different kind of communication or protocols or traffic to flow between. Or even another case would be, let's say there were 2 admin machines and one we did want to open up, we would need to get more fine-grained with our access control list to say, hey, you can speak to this particular host in admin, but not this other host in admin. And it would be the same thing, just modifying our access control list to, allow or permit or deny additional scenarios. And don't forget that at the end of an access control list, there is an implicit deny. So you must permit stuff, else everything is going to get dropped by default. Okay, if you watch this and you spotted anything that could be made better or maybe a mistake in anything that I said, please let me know in the comments. Like I said, I'll do more of these, just kind of come up with what seem like real world scenarios. All right, it is just at the end of the lunch hour. Everybody have a good rest of your day, a good rest of your week, and I will talk to you later. Bye.